sorry, it's lesson 5, scaling an area, okay? And this is the practice. So let's get right to it. So here's a lesson summary. The scale factor describes how the side lengths of a shape change when it's scaled, but it doesn't directly describe how the area will change. You can use reasoning about the scale factor to find the area of a scale copy. Here are some strategies to find the area of a scale copy. So, the easiest way, and I think I didn't even bother reading it, but if this is the original, so let's talk about the shapes. That's the original. What's the area? Well, the area is the number of square units inside. In this case, there's 1, 2, 3, or you could have just multiplied 1 times 3. And the area is 3. What's the area here? Well, again, you could have said, oh, Mr. Cho, that's easy. It's 2 times 6, right? And that is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, if you notice what we did today, and then let me rewrite this. And we wrote original. We write perimeter here. An area. So let's go over what we did today. In the original shape, the perimeter is 1, 2, 3, 4, 5, 6, 7, 8. To walk around that shape, it's 8. 8 units. The area is 3. Now, with a scale factor of 2, right? Let me write scale factor 2. Now notice that the height of 1 is now 2. The length of 3 is now 6, right? So we use a scale factor and to find it. And how did it affect the side lengths? Well, the side lengths doubled. So that's the easy part. Now let's take one step further and find the perimeter. It would be 2 plus 6 plus another 2 here and plus another 6. 6 and 6 is 12, 14, 16. Or, if you look at the 8, right, you could have said, hey, the original perimeter of the figure was 8. The scale factor is 2, so 8 times 2 is 16. But you'll notice that that doesn't work for area. So if you take the area of the original shape, which was 1, 2, 3, and you simply multiply it by 2, you get 6. But you can clearly look over the scaled copy and notice that this is not 6. It's actually 7, 8, 9, 10, 11, 12. So this is 12. So how did we discuss this in class? Well, we found a pattern, and the pattern was that to find the area of the scale copy with a scale factor of 2, or any other scale factor, but let's talk about scale factor 2, is to do what? Take the scale factor, square it, multiply it by itself, and then multiply it by the original area. So if we take 3 and multiply it by 2 to the second power, 2 to the second power is 4, so 3 times 4 would be 12. Look. Let's try another one, scale factor of 3. If you take a scale factor of 3, and I'm going to draw it out here, right? So from the original rectangle, this height will be 3, and this will be 9. Right? So if you want to take your dog for a walk and walk around this particular rectangle, it'd be 9 and 9 is 18. 18 plus 6 is 24. Notice that you could have just multiplied the original perimeter times 3, the scale factor, and given you 24. So to walk around this is 24 units. But what about the area? What if you didn't want to draw? Right? So if you didn't want to draw, right, or count, well, you can obviously you can multiply 3 times 9 to get 27. But what is the pattern that we're looking at? Well, the pattern says that if I take the scale factor, square it, so in this case, scale factor to the second power times the original, so that's what we talked about. So the scale factor that we're talking about is 3, so take 3 to the second power times the original area, which is 3. 3 to the second power is 9, and then times 3 gives you 27. And notice that it matches. Right? There's 27 square units in that. Okay? So the pattern was, and again, I'll do one more. God knows if anybody is still watching, but scale factor 4. What happens to this shape here, the original, if you increase it using a scale factor of 4? Well, the perimeter, what would it be? Well, the original perimeter was 8. And multiply that by 4. Now you're going to get 32. But what about the area? What would be the area of that scaled copy? Well, you would take the scale factor, which is 4, raise it to the second power, and multiply it by 3. 4 to the second power is 16. 16 and 3 would be 48. Okay. All right, so let's look at this one. Oh, no, this one. Draw a scale copy of polygon Q using a scale factor of 2. Well, that means that, let me write some numbers. This is 1, 1, 2, 3, 4, 5. That's 5. That's 2. That's 4. And that's plus 1. So if it's scale factor 2, all the side lengths are going to be doubled. So this is going to be 2. That's going to be 2. That's going to be 2. That 4 is going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. And that 2, the height here 2 is going to be 4. 1, 2, 3, 4. And this distance of 5 is now going to be 10, I hope. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There. There is the new shape. So, is that it? No kidding. Now, what is the area? Now draw it again, because mine got erased. Oh, there you go. What's the area of that shape? Well, going back to what we did, right? So let me write original. The original, the perimeter, and we don't need a perimeter, so we're just going to do area. So the original, what's the area? The area was 1, 2, 3, 4, 5, 6, 7, 8, 9. The original area was 9. We did scale factor of 2, right? So this shape, the side lengths, all the side lengths got doubled, right? Using scale factor of 2. So this is 10, this is 4, this is 8, this is 2, this is 2, this is 2, right? Everything got doubled. But what's the area inside? Well, going back to what we talked about, what do? We take the scale factor, we raise it to the second power, and then multiply it by the original area. What's the scale factor here? Scale factor is 2. Raise it to the second power times 9. 2 to the second power is 4. Times 9 gives you 36. So the area is 36. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's something wrong here. Something seems a little off. Hang on a second. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. No, we're good. Sorry, I doubted myself. 4. Okay. Complete the table. Oh, now we do sort of what we did in class. So, scale factor of 3. Let's do the ones that we can. Scale factor of 3. So this is the original, right? The perimeter is 14. The area inside is 9. That works. So this, let me, 1, 2, 3, 4, 5. That's a 5. This is a 2. This is a 4. That's a 1. That's a 1. And this 1. Does it add up to 14? Yes, it does. Is the area inside 9? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. So let's do a scale factor of 3. Scale factor of 3, right? And we want to find the perimeter. All we got to do is multiply 3 times 14, which gives us 42. And what do we do with the area? Well, we're going to take the scale factor of 3. Okay. Take the scale factor of 3. We're going to raise it to the second power. And then multiply by 9. What's 3 to the second power? It's 3 times 3, which is 9. Times 9 gives you 81. So this would be 81. Now, what's the scale factor? Okay. That gives us a perimeter of 28. Well, if the original perimeter was 14, 14 times what? 28, obviously, is 2. So, what is the area of this shape when it's scaled, when all the side lengths doubles? Right, so we take the 2, raise it to the second power, and multiply by the original, which is 9. 2 to the second power is 4, times 9 gives us 36. Five. Oh. How is the relationship between the scale factor and perimeter different from the relationship between the scale factor and the area? Well, let me fill in some numbers. 2, this was 42, this was 36, and this was 81. To get the perimeter, all you gotta do is multiply 2, so 2 times 14 gives you 28. 3 times 14 gives us 42, right? So to find the perimeter, you multiply the scale factor, right? To find the perimeter, and we wrote this in class, it's the scale factor times the original, right, of the original perimeter. To find the area, we're going to take the scale factor, raise it to the second power, and then times the original area. So that's the difference. Okay? Six, Ivan created a copy of rectangle A. The ivory scaled copy is 48 square units. So, okay, how many times greater is the area of ivory scaled copy than the area of rectangle A? So there's this rectangle that was built. So ivory created a bigger one, much bigger one. And in that bigger one, okay, the area, so you can tell the area of this one right here that the area is 3. She made a scale copy, so made an enlargement, and the area, obviously not this one, right? She made a rectangle, same rectangle, and it was 48. Okay, how many times greater is the area of ivory's copy than the area of rectangle A? Really, is that the question? So in this case, this is 1 and this is 3. So think about what numbers we could have put this. So if there was a, why did I write area is 3? Oh, the area is 3, I see what you mean. So if we put it, I mean, let's give it a try. If we do a scale factor of 2, for example, this would be 2 and this would be 6. Is 6 times 2 48? No. If it was a scale factor of 3, this would be 3, and 3 times 3 was 9. Is 3 times 9 48? No. Let's try 4. This would be 4. 1 times 4 is 4, and 3 times 4 is 12. Stop. Is 12 times 4 48? Yeah, the area here is 48, right? So what's the scale factor that was used? The scale factor that was used to create this rectangle whose area is 48 would have been 4. I recreate a scale copy of rectangle A. Okay, the area. I think I just answered that question. Okay. I have to edit the video. So here's a right angle triangle. They don't give us a measurement, but they tell you that if you were to count the squares that are inside, you would find 36 of them. Okay, there's 36 in here. Now that's all we need, right? I don't even need the dimensions anymore. So if somebody said, hey, let's use a scale factor and double this triangle dimension-wise, right? So it got bigger by twice the dimensions, right? How many square units are inside here? Well, we know the pattern, so we take the scale factor. So we take the scale factor, raise it to the second power, and then multiply by the original area, the area of the original triangle. We're good. So the scale factor here is 2, so we're going to take 2, raise it to the second power, and multiply by 36. 2 to the second power is 4, and 36 times 4 is 144. All right, so Now, going with that same train of thought, let's do scale factor of 3. What happens if we increase the dimensions of the original triangle by 3? Well, what would be the area? How does the area grow? Well, it would be 3 to the second power, right? We're going to take the scale factor, raise the second power, and then multiply by the original, which was 36. And 3 to the second power is 9, and we're going to multiply by 36. 9 and 6 is 54, carry 5, 9 and 3 is 27, 23, 32. So that's 324. What if it was a scale factor of 5? Well, take the scale factor, raise it to the second power, and multiply by 36. 25 times 36, sorry, 5 to the second power is 25. Now multiply that by 36. And you're going to get 900. Oh, we haven't done fractions. Well, it's the same idea, but now our triangle, well, if the scale factor is less than 1, what do we learn? It's going to be smaller, right? So what is the new area? You know, same idea. Scale factor is a half, yeah? Raise it to the second power, and then multiply by the original area, 36. What's a half times a half? Because that's what it means to take it to the second power, right? Multiply by itself. Well, half times a half is 1 over 4. So half to the second power is 1 over 4. Times 36. So what's 1/4 of 36? So let's say you had $36 and I took 1/4 of that. Well, it's the same thing as 36 divided by 4, which is 5. So 1/4 of 36 is 9. Okay. And we have one more. So again, it's a scale factor of 2/3, so the triangle, the area is going to be smaller than the original. So we're going to take 2/3, the scale factor, raise it to the second power, and then multiply by 36. 2/3 times 2/3, it's 4 over 9, yeah? So now we take 4 over 9, multiply by 36. We can simplify across. 36 divided by 9 is 4. And 4 divided by 4 is 1. So the area, what? Really? 4, 9, 13. What am I doing? Sorry. Not 1. Take it back. Take it back. 9 divided by 9 is 1, so that's a 1. 36 divided by 9 is 4. Sorry, 4 times 4 is 16. Bad. Eesh, yuck. Alright. So, it's been a busy day. Oh no. And I gotta turn this on again. Sorry, bear with me. Jeez, just not my day. Alright, here we go. So, we're supposed to find the area of the shapes, right? So, let's see, let me just make this like this. And what they tell us is that the area of this shape is 1. 1 square unit. Which means, right, how do we find area of a square? Area of a square multiply the side. So that means that this guy is 1 and this guy is 1. Okay? So the perimeter, if you walked around, it would be 1, 2, 3, 4. And if we talk about square units, this one, right, this particular one is 1. So they have it written for us that this area of this, which was letter D, and I kind of wrote all over it, is 1. So let's find the area of A. So if you look at A, what can we say about A? A, if you look at this side, the sides, right, is double the sides of this one, right? So this guy is 1, 2. This guy is 1, 2. So we know that for A, the dimensions were increased by a scale factor of 2. Now so if we know that the scale factor is 2, how do we find the area of that? How many square units are in there? Remember what we did? We took the scale factor, we raised it to the second power, and then we multiplied by the original area, and the original area was 1, right? The area of the original shape. So 2 to the second power is 2, times 1 is 4. And we can clearly see here, look. Isn't that 1, 2, 3, 4? Yeah, right? So that's A. B. B if you can see that B, if you can understand or see that B, right? If you think about A, right, and you cut that, and they cut that in 4 parts. This is 1/4, this is 1/4, this is 1/4, and this is 1/4, right? So B is 1/4 the area, has the area that was 1/4 the area of A. So we know that A is 4, so if you take 1/4 of 4, the area would equal to 1. Okay. C, well now C, if you look at C, this would be 1, 2, 3, 4, and this would be 1, 2, 3, 4. So they use a scale factor of 4 to go from the original one, which was this one, to C. So scale factor is 4. You take 4, you go to the second power and multiply it by the area of the original one. 4 to the second power is 16 times 1 equals 16. So that would be 16. E, where is E? Well, what is E? E is half of what of A. Can everybody see that E is half of the area of A? So half the area of A, and the area of A was 4. So half of 4 is 2. Okay. F, if you look at F, which is right here, F is half the area of C. Do we have C? Yeah, we have C. C was 16, so if we go half of 16, we know that it's 8. And G is 1/4 of C. 1/4 of C, which was 16, and we get 4. All right, pretty nice problem. The last problem, this one is surface area. So we just have to find the area of all these shapes, add them up, and we are good. So let's start. Let's do that rectangle over there. So apparently, I don't even know if they're the same. Let's take care of this guy here, and this guy. If they're all the same 3 rectangles, what's the, well, for the rectangles, the small ones, base is 3, right? This guy is 3 over here. And what's this? This is 1.5. So it's 3 times 1.5, which is 4.5. But there's 3 of them. There's this one, and there's this one. So it's 4.5 and 4.5 and 4.5. So if you add them up, you get 15, 16, 17.5 just for the rectangles. Let's take care of the triangle to the left, this one. The base is 15. God, I hope I'm reading that correct. So this triangle, base times height, 15 times 13 divided by 2, right? And if we do that, 15 times 13 divided by 2 gives us 97.5, right? But because there's another triangle on the other side that to me looks the same, so we're going to go back, multiply by 2, we get 195. What do they want? They want the area of the surface area of the triangular prism. Okay, so $195. Sorry, I did this wrong. It's not 1.5. I know what my mistake is. It's, apologies. This is 3 and that's 15. So it's 3 times 15 for, I'm doing the rectangle by the way. that little, that width is 3, the height is 15, so 3 times 15 is 45, and we have 3 of these rectangles, so times 3, 15, 135. So if I add 195, which is the area of the 2 triangles, plus 135, which is the area of the 3 rectangles, 10 goes 1, 3, 330, and there's our answer right there.